Throw my hands up and shout, throw my hands up and shout, throw my hands up and shout, throw my hands up and shout. Come Colorado, Rocky Mountain High. I've seen it rain, fire in the
California, Texas are so high! I've seen the wildfires from the sky!
and thus the fever dream begins.
Thunderstruck!
Since we are given that the disc is 5 meters in diameter, we can assume that the radius is 2.5 because the radius is half the diameter and half of 5 is 2.5, and the angle that the string is tilted is 20 degrees Celsius or 69 degrees Fahrenheit. Wait, hold up, JK, do not put the Celsius in the degrees, okay? We know that the car is in motion when it's spinning around, so that would mean we have to use Isaac Newton's second law. But at this time, it's running around in circles, so there will be centripetal acceleration. So, but then the other thing is, we're looking for the velocity, and we're given radius, so we don't have acceleration, so we can just substitute acceleration with just v squared divided by r, v being velocity and r being radius. So yeah, we'll plug that in later. So now we have to get the horizontal and the vertical components. So here we have tension in this graph, no, in this diagram. So we have to split tension to t cosine 20 degrees and t sine 20 degrees. So t sine 20 is the horizontal component because the 20 degrees is relative from when the rope is vertical. So yeah, that's why the cosine is the vertical component. So anyways, you get the x component where mass times centripetal acceleration equals tension sine 20, and the horizontal component is m times gravitational acceleration equals tension cosine 20. But remember, as I keep saying in my videos, G is 9.81 meters per second squared.
If you say it's 10 meters per second squared, you lost your kneecap privileges, okay?
So first we need to isolate theta. So first we have to divide the horizontal component by the vertical component. So you get this conglomeration. So from the left side, the m's cancel out since it's both on the numerator and denominator, and tension does the same thing as well. So yeah, and that, but then if you know your trig functions, you know that sine of theta divided by cosine of the same angle will equal tangent theta. So there you go, and and an acceleration divided by g will equal the tangent 20. But then we need to isolate a, so we have to put the gravitational acceleration. We have to put the gravitational acceleration on the other side, so it's g tan 20 equals a. And now, since we do not have a, and we're looking for v, and we're given r, and the car is going around a circle, the a will become v squared, excuse me, divided by r, and there you go. Now what you do, you multiply r by both sides to isolate velocity squared. So yeah, and now the final part is you have to square root both sides, and then you have v. To finally end this video, you have to plug in the numbers. So r is 2.5, g is again 9.81. So there you go. And then the tangent of 20 degrees, make sure your calculator is in degrees, not radians. Is about 0.3639702343, or just 0.36, just to go with just to be a little more accurate. So anyways, now you multiply what's inside the square root, and you get 8.9 degrees. I don't know why the parentheses is there. So you get the square root of 8.9, and then your velocity is two. Wait, it's about 2.98770313 meters per second. So this this is your answer for this is your answer for this whole equation. So yeah.